It's very simple to check what type of return to scale is present for a Cobb-Douglas production function. A Cobb-Douglas production function is given by f of x1, x2 is equal to capital A times x1 raised to a times x2 raised to b, where capital A, and b are all positive constants. If a plus b is equal to 1, then there is a constant return to scale. If a plus b is greater than 1, then we have an increasing return to scale. And if a plus b is less than 1, then the production process displays decreasing return to scale. Let's prove this formally. So we have a production function, y equal to f x1, x2 given by a, x1 to the a, x2 to the b. We want to investigate what happens when we change scale. So we do tx1, tx2. I need to replace all x1 with tx1 and all x2 with tx2. So I get a, tx1 raised to a, tx2 raised to b. This is the same thing as a, t raised to a, x1 raised to a, t raised to b, x2 raised to b. And if I collect the t's, it's t raised to a plus b, x1 to the a, x2 to the b, where this part here is my production function, so I can write this as t a plus b f x1 x2. I want to compare this to t f of x1 x2, since if this is equal to this, we have constant return to scale. If it's greater, we have increasing return to scale. If it's less, we have decreasing return to scale. So let's rewrite this t a plus b as t raised to a plus b minus 1 times t. That is exactly the same thing. If I add the exponents of this expression, I have a plus b minus 1 plus this 1 here, and that's a plus b, so these expressions are the same. That means that I can write this as t raised to a plus b minus 1 times t f x1 x2. I want to do that because what I really want to do is to compare this expression to this expression, and I have isolated this factor in front. So we now see that if a plus b is equal to 1, then t of a plus b minus 1 is just t to the 0, which is just 1. So that means that this factor disappears when a plus b is 1, and we have the new production function is equal to t times the old production function, which is precisely constant return to scale. If a plus b is greater than 1, then a plus b minus 1 is greater than 0. Well, that means that t raised to a plus b minus 1 is greater than 1 if t is greater than 1. If you pick the base to be greater than 1 and the exponent is strictly positive, you must get a number which is strictly greater than 1. That means that this expression here, my new production level, must be greater than t times my old production level. So we have increasing return to scale in this case. The last case is very similar, a plus b less than 1, then a plus b minus 1 is less than 0. This factor here must then be less than 1 if t is greater than 1. T raised to a plus b minus 1 must be less than 1. In a power, if the base is greater than 1, and the exponent is negative, then the power must come out to be a number which is strictly less than 1. So if t is greater than 1, and again, that means the new level of production is less than this t times the old level of production. So that is what we mean by decreasing return to scale.